नमस्कार दोस्तों, मैं हूं आपका होस्ट रोहित एंड वेलकम टू अवर यूट्यूब चैनल रोहित स्टॉक। It took a lot time to make another video as I was busy in some another personal work. So let's start today's our topic with characteristic evaluation of calorimetry. Calorimetry can be either purchased or built, both of which are challenging tasks. When purchasing, it is difficult to evaluate the performance because companies are not inclined to state the disadvantages of their product, and there can be reason specific to the experiment that make commercially available calorimetry inadequate. On the other hand, building a calorimetry requires a certain level of expertise on the subject. For a given experiment, the optimal type and design of reaction calorimetry depend on detail of experiment and the process being measured. Hence, the majority of literature on reaction calorimetry is specific to the type of process. This video will detail the characteristics that must be taken into consideration when evaluating the performance characteristics of reaction calorimetry. The performance of reaction calorimetry depend upon design characteristics like pressure range, stirring capacity, reactor volume size, and heating and cooling rate. Although the most important characteristics are the measuring principle and the temperature control method. In this video, we considered precision, accuracy, calibration requirement, temperature resolution, and temperature control for evaluation of characteristics of reaction calorimetry. First, precision. It is the variation in the measurement of heat flow from the same control source like Joule heater, filter element, or jacketed heat transfer surface area. Second, reproducibility. It is the variation in the measurement of heat flow from different source and method. Third, accuracy. It is a systematic error between the measured value and true value. Systematic error can be originated from the calorimeter and also from the detail of measured process. For example, there can be drift in calibration constant causes by property of calorimeter, or unmeasured variation in heat losses from the variation in temperature outside of calorimetry. Also, the importance of systematic error depending on the nature of measurement. For instance, a calorimeter with a drifting calibration constant can be accurate for the measurement of short duration, even though it is inaccurate for extended measurement. Fourth, linearity error. Linearity error is the maximum difference between the heat flow balance equation and the actual functional relationship. In reality, perfect linearity error can never be achieved. If linearity error originated from dependence of calibration constant on variable such as a temperature or voltage, linearity error is avoided or reduced by defining the dependency through calibration. The amount of linearity error in calorimeter that is not avoided by calibration should be specified by the manufacturer or the operator or experiment based on experience. Fifth, calibration requirement. Calibration constant can be affected by various factors such as a liquid level, viscosity, phase, temperature, agitation, position of heat source. Power compensation and Calvert calorimeters require fewer calibration than heat flow calorimeter. Calibration requirement depending on design of calorimeter. Fully insulated heat balance calorimeter have no calibration requirement except identifying the jacket fluid heat capacity if it is not already known. Method of calibrations. First, known heat input by Joule heater. Second, standard chemical reaction. Example, neutralization. And third, for endothermic reaction, calibration method are limited the filter effect and endothermic chemical reactions. Temporal resolution. Temporal resolution is a measure of calorimetry's ability to measure the heat flow from transition process. In general, increasing temporal resolution allow for more information to be obtained about process. There are three factors that contributes to calorimetry's temporal resolution. First, its time constant. Second, the heat accumulation of component. And third, time constant of sensors. Calorimetry's time constant is the time required for it to reach a thermal equilibrium after pre-turbination in reaction heat flow. Time constant of calorimeters are determined empirically from measuring the time for heat flow to stabilize after a known heat impulse has been applied from a known heat source such as a Joule heater. The time constant of calorimeter must be known and in order to experimental data. Seventh, temperature control and temperature range. A reaction calorimeter's temperature control capacity is important because temperature affects the reaction rate and because the measurement of heat flow in non-isothermal condition is more complex and less accurate. Temperature control or cooling capacity of calorimeter affects its temporal resolution and therefore also affect the amount of information that can be obtained about the process. Phi factor. Phi factor is a correction factor which is based on the ratio of total heat capacity of vessel to the total heat capacity of its content. Phi factor concept applicable to reactor as well as storage vessel, evaporator, distillation column. Also, phi factor in large chemical plant are often between 1 to 1.05. Dynamic phi factor difficult to calculate. Importance of phi factor. Suppose in adiabatic calorimetry phi factor is 2. It means that observed adiabatic temperature rise in adiabatic instrument will be only half of the true adiabatic temperature rise for the chemical alone. And its consequences are: first, experiment is not performed over the correct range of temperature, and second, failure to detect consecutive reaction and gross underestimate of the rate of reaction may result. It is always better to the phi factor is close to unity and normally in the range between 1.05 to 1.1. To achieve the objective of low phi factor, the test cell mass must be as low as possible. Here we considered different calorimetry with their phi factors for scale up of process. तो आज की वीडियो में सिर्फ इतना ही. If you really like the content, please like and share the video and don't forget to subscribe our channel. You can also connect with us on Facebook, Twitter and our blogs. Links are shared in description box. तो मिलते हैं हमारे अगले वीडियो में. तब तक के लिए मैं रोहित साइनिंग ऑफ. बाय बाय.